Thanks everyone for coming. I'm really excited about this fireside.
Excited to be here.
Ashish and me have been working at Google before. For those who are not familiar, Ashish is one of the co-authors of Attention is All You Need. The last time we were on stage was actually with Jensen and the rest of the co-authors, except Nikki, at GTC in 2024. And I've been trying to pull him in ever since.
we have to schedule our catch-ups better. It shouldn't just be on stage all the time. But now that you're in San Francisco, welcome. We can do that more regularly.
Exactly. And so I will let Ashish introduce Essential and kind of what he's been working on. But yeah, really excited to talk about open weight models. Why this is important, why it's important for us to have this in the world, as well as how do we really kind of continue advancing the science here. So Ashish, take it away.
I'm the co-founder and CEO of Essential, and as Ilya mentioned, and very relevant to the conversations here, we care about bringing open source models to the frontier, open weight models, and our focus is coding and STEM. And our first model release was last year in December. We released Range 1, named after one of my heroes and favorite mathematicians, Ramanujan. And Ramanujan is an 8 billion parameter model that it aces coding and STEM in coding and STEM capabilities, and it punches above its weight for the weight class. So I think to the extent that it's important, and I believe it is, I think it was the best American open weight model in its weight class, and we've gotten great feedback. Lots of people have been coming back and using it in their applications very recently, actually, and this is where open weights are actually important. Telco has been open weight models are very important for telco, so we've been finding some nice accuracies there on their tasks. Yeah, great to be here.
Yeah, so I think I agree that like you guys effectively released one of the few, I would say, open weight models that coming out of effectively not China. Like right now, if you're using kind of open source open weight models, they're mostly coming out of Chinese labs. And although they've definitely been benefiting community, there's challenges. Like a lot of businesses cannot use them for a variety of reasons. There's challenges with like not knowing the provenance of data that went in. And we just had an article from Anthropic saying that like there's massive scraping happening. So one question is, what got you to say, hey, we're gonna open source this model? Like what got you to on this path?
I think it's so. This is a great question, and some people are idealistic about open source and open weights. I don't even think that we need to be idealistic about it. If this is provably, unimpeachably going to be the most important technology that we ever create as a species, we barely understand it today, and I think we need more and more models out there, controllable, for us to be able to interrogate them, probe them, and understand them, understand the extent of their capabilities to fully adopt it in society, right? So I think that even practically, it's important that there be open weight models for us to understand how AI works and how we can improve it for everyone. Obviously, as a scientist, and that's how our work started, I think that we all stand on the shoulders of giants. We have stood on the shoulders of giants. That's how science has advanced over millennia, and I think open weight models is just another means of continuing to advance the craft. I personally believe the craft must be open. There is still a tremendous number of open questions remaining, like 100x efficiencies waiting to be squeezed out, and open weight models and open source AI is a way of advancing that craft, and it needs to be open. Yeah.
Yeah, I mean, obviously the transformers, when they came out, were open source.
Yeah, imagine if it was kept in a safe somewhere, right? Well, I guess you and I wouldn't have so much opportunities to catch up, I suppose, but yeah.
Yeah, I mean, the interesting thing is obviously like, if it wasn't a safe, nobody would actually even know this is a thing because it wasn't really part of any kind of product at the time, right? It was a research project that was bringing together effectively like 4 different like teams working on it. And so the opportunity of really collaborating, really opening it up, and really everyone contributing is just tremendous to enhance how we understand it, but also how we develop this technology, and really bringing more on board who can actually do this as well.
I think you raised an excellent point. If you think about it, I mean, one big difference in how research changed in the last, I would say, maybe now, I guess close to a decade, right, is that there were young, brilliant startups that actually did some of the most advanced research, and now they're some of the most sort of, they're some of the iconic companies of this generation, right? But to your point about, is there an institution, is there a single large institution that is actually doing frontier work in the open that allows us to, allows the entire world to, allows not just closed but open models to move lockstep in our understanding to advance. I don't think there exists such a lab that is doing frontier work today. There doesn't exist a single institution, and I think that we would benefit from that. I think we would benefit from it. Yeah.
Yeah, I mean, I think that this has been the challenge of the incentives, right? This work requires immense amount of resources, computing first, and then obviously people second. And so there's no for-profit company that would be like willing to open up their frontier. And then on the other side, the academia just doesn't have resources and is not able to raise resources because it doesn't have kind of a profit machine underneath. And so, I mean, this is where, in theory, crypto is actually the instrument to really facilitate that. But obviously, it also, there is a divide between kind of AI researchers and really crypto world that hopefully we can bridge this with this conference and community that we're building.
And I think that I think we shouldn't forget that there's still a ton of work to be done. There's still important work to. I mean, this is no more just number one. This is no more just a single architecture. It's a system, right? Like the Wright brothers were. I mean, it's funny. The analogies to how to building the first planes is I think quite closer than we might think. For instance, everybody could look up and realize that yes, physics allows for flight, but then all the physicists of the time didn't think that you could have practical planes, right? But what did the Wright brothers didn't come up with new theories in physics about flight. They basically solved a systems problem. In fact, from what I understand, they built a wind tunnel. They actually simulated they simulated flight, right? So I think that there's so many aspects of this system that can be improved, and there is good work being done, and there's a lot of great work to be done. I think the resources question is critical. I don't expect us to collapse the gap in intelligence per dollar within a month or something. It's going to take some time. So I do agree that finding something like an organization or a mechanism to organize the resources, organize research and resources is important. Yeah. Along with the system, the productionizing and bringing these production systems into applications as well.
Yeah, getting applications, getting actually monetizing them to feedback and create the system, but that promotes science, promotes kind of open weights.
And to some degree, we're obviously we want to do that at Essential. I mean, and at the same time, we have to create a business we will be. Our goal with putting open weights models is both adoption, also getting contributions back from the world, understanding how our models are used in environments, and we've learned quite a bit with our release, and then bringing that into our fold that advances our research roadmap. So this is how we aim to balance it. I think there's other ways of doing it, I'm sure. Other ways of balancing these two worlds as well. Yeah.
So maybe switching gears, I think what's really interesting is what other open areas, right? Because I think there is obviously right now, first of all, there's a meta camps, which is AI good or is AI bad, right, for society, right? Removing that for now.
Thank you. Yeah.
But also hey, is the frontier companies, which, are they just on the drumbeat and just they're going to continue to dominate and it's just more scale, right? There's just more of the same at larger scale, maybe cleaner data, and that's all? Or there's actual science, there's actual innovation, there's new ideas that coming in. And I mean, the question I get asked a lot is Transformers the final model, or are we going to have another one, right, that is better? So I'm curious to hear your thoughts here.
I'm surprised you don't get asked if Transformers is all you need, but I think there's truth to both, right? And this is somewhat a sobering thought, but I do believe that there is the path of pumping in more resources in the existing protocols or the in the putting more resources in the existing way of doing things will give us benefits as it continues to. We put miraculous amounts of resources and we got miraculous results in coding, right? I think that's a very, I mean, some of the coding models are very impressive today, what they could achieve vis-a-vis last year, right? So I expect that to continue. But at the same time, like I said, there's advancements we continue to make in all the areas that you mentioned, right? I mean, so yes, fundamentally, we're trying to predict the future from the past, right? That's kind of what we do with sequence prediction. I think even, and I think that's a very general and important framing of the problem. I believe that we're very fortunate that we have algorithms like gradient descent that automatically learned from data the patterns and the programs that explain that data, right? And then there's another constraint that we must keep in mind, which is physics, modern accelerators, right? And that has played a role in how architectures have advanced. But I think I believe there's still important advances to be made in architectures, right? The transformer was very effective at mixing, having these short wires that mixed information locally and these long wires that mixed information spatially and globally, right? And they turn out to learn patterns more effectively, right? For at least some class of problems. And now, if you scale it up, nearly like all class of problems. I think understanding, for instance, even on the data side, what is the value of a particular signal, like a document, what is the influence it can have on the behaviors that you care about, is another open problem, right? And you can think about interpretability as some part of this. There's enormous work to be done and I don't know why this isn't happening as much as it should, but everybody should be building environments, right, where open weights models can participate and learn from. And I think there's a lot of important work to be done there, evaluating model behaviors. So you just, and long contexts. Long context is obviously, I think, the holy grail. It's a fundamental problem. And depending if you're a model maximalist where you just believe that we should figure out how, we should extend memories unto infinity, or we should have, mimic what what we have done with architectures, have hierarchies of memories, right? So there's, just in this conversation, in this last minute, there's so many problems that have come up. I think that there's limitless amount of interesting problems to work on. Still a lot of good work to be done. Yeah, and that's why we're optimistic at Essential. Yeah.
Yeah, I mean, I think there's all of the things you've named, right, and even the gradient descent, right, which is indeed seems like a magic, but at the same time, it's highly inefficient from perspective of physics because it effectively requires global computation over the whole model, right. Which means you have a limit on how big models can be. You have a limit on how much compute you need to actually do this, memory. And so, I think there's opportunity at every level of scale. And we know the systems are highly inefficient, right? You need to show it a piece of data, a piece of pattern thousands of times
to
really remember it, which is clearly not not how we learn.
Right. I mean, I think every researcher that we've met has had a dream about data curricula, but has scars from it as well, right? And again, many researchers that we met have probably dreamed someday I will defeat gradient descent, and they only come back with scars. So just remember these words. But I agree with you. I wonder, why can't we just look at data once? Just all the data once, and we've learned, and we would squeeze out as much information as possible, bring it down to its irreducible entropy, right? And maybe another way to say this is, okay, yes, we fed the model the internet. Have we compressed it completely? Because ultimately, that's what we're trying to do when we're doing next token prediction, right? We're trying to compress all the knowledge, all the skills, all the reasoning on these models. Have we compressed it to its irreducible limit? I don't think so. So there's a lot more work to be done there, yeah.
Yeah, and I think that the other interesting thing that's happening is the internet is effectively becoming AI generated, right? And at the same time, it's shutting down. Like the websites are starting to rate limit, being able to scrape them. And so there is actually an interesting problem that's happening is that the labs who started earlier have scraped internet before the internet shut down and created a lot more AI generated content. And so it's actually half human data that new labs and new approaches may not have. And so how you think of dealing with that? And I mean, obviously, you guys need to actually deal with that as well.
100%. Like at one point of time, we were simulating. One point of time, we were simulating what humans thought, and now we're going to simulate in our models what models thought, right? And then, I think. But by the way, this is probably already true of GitHub, right? How much of code that if you train a model on GitHub today, how much of it is actually just going to mimic the sort of imaginations of Claude, for instance, right? So the good and the bad, right? Technically, you can take this point that you made and reduce it to a question of what is the composition of natural, that is human-generated data, and synthetic data that you actually the right composition to create the blend of capabilities that you care about, right? So fundamentally, it is a question of that. I think the issue that you're pointing out is, can we distinguish between these two, right? I mean, if we're not able to distinguish between these at all, then I think we've reached we passed the Turing test, so we're good to go. Then we're done. But I think we can, and ultimately it's a technical question of how much of this inorganic or synthetic data, along with natural distributions, creates the right composition of abilities for the behaviors that you care about. But here I want to say that I cannot explain how much I appreciate and revel, or how much I appreciate human cognitive accomplishments, and I perhaps I might feel a little unhappy if our trace or the pulse of human cognitive thought is being wiped out, and that does disappoint me a little bit. I think there's a lot of beauty in what we have, in the knowledge and skills, in our knowledge and information that we've produced, and I hope that we will continue to enjoy it, and the models will also benefit from learning from it. Yeah.
So are you more pro uploading our mind into the into the net, or effectively keeping the, I don't know, guarded, only humans allowed?
That was a very abrupt transition to very abrupt speculation. But if you were asking me, I think the hybrids are an interesting strategy. Yeah, you referred to extremes. I'll leave it at that. Yeah, I'll leave it at that.
Yeah, so I agree. I think there's a lot of opportunity right now. I mean, the current model training is extremely inefficient, extremely resource intensive. I think this is where it's a really weird state right now where, you guys built 7B model. That's still pretty resource intensive, right? It's not something that even academia is able to do. But this starts to be the size where you can actually do actual science, because this is where some of the emerging kind of phenomena are coming. Do you think there is an opportunity to do science on smaller models and with smaller compute to really get the properties out? Because I think that's really been the challenge.
I think this is a fantastic question, and when we shared our journey through Range 1 in our blog, we wrote that trying to pick out these signals that are invariant at different scales is an extremely important and difficult problem, and we succeeded to some degree, but I believe that we haven't completely succeeded there. I think that there is still, depending on the kinds of behaviors that you want to detect, like at smaller models, there's very little signal over noise. And that's the benefit of actually running experiments at scale. But then maybe, let's say we want to measure a mathematical reasoning ability, and a 1 billion parameter model is inept at showing any sign. Maybe what we need to figure out is a better way of measuring it and getting these traces early on, so that we can significantly improve the researcher iteration and cost of scientific iteration as well. I wouldn't say that we have an answer to this, but I think you raise a good point. That's one of the questions that we do care a lot about at Essential, and we do benefit from by getting more and more applying the scientific method, first principles thinking, and being very rigorous in how we iterate over our ideas.
Yeah, the first transformer, right, was ran on CPU, and we could see some signal from the noise, right? That was but it's pretty dramatic now that like, yeah, beyond just basic language modeling, like if you want to see actual capabilities, you need just massive models.
You know, I actually calculated this. So I believe I mean, I guess on a the last generation of GPUs, we could probably do the English-German experiment. Oh, no, no, on the latest generation of GPUs, or a single device, you could probably do the English-German experiment in an hour or so, just by the flops itself,
Yeah.
right? I think I think relative to 2017, we have enormous resources, and maybe this is the worry that we're relegating a lot of our intelligence to AIs and not focusing a lot on good science. Sorry.
Yeah, so no, I really appreciate you coming. This is all the time we have. I mean, as you know, we can speak for hours about this stuff. But thank you very much for listening to, and hopefully you picked up some of the ideas where to invest in the future with your time and efforts in building this amazing future. Thank you.
Thank you.